In this video, I'm going to discuss about uncertainty. Under uncertainty, we are going to discuss about Maximax, Maximin, Minimax regret criteria. As now you know, the main difference between the risk and uncertainty is that risk is quantifiable, which means probabilities can be assigned to each possible outcome. When it comes to uncertainty, it is not quantifiable because we cannot assign probabilities for possible outcomes. We also discussed about risk attitudes. Risk attitudes refers to the amount and type of risk that an individual or an organization is willing to take on in pursuit of their goals and objectives. In other words, it is the level of risk that an individual or an organization is comfortable with. There are three types of risk attitudes. Risk averse, or this is also known as risk avoiding. Risk neutral, and lastly risk seeking or risk loving. This is also known as risk taking. What is risk averse or risk avoiding? These are the individuals or organizations prefer to avoid taking risk and prioritize safety and stability over potential rewards. For an example, a company may choose to invest in low risk bonds instead of high risk stocks because they value stability over the potential for higher returns. Simply means these are the individuals or organizations who do not like to take risk. Risk neutral. These are the individuals or organizations are indifferent to risk and make decisions based solely on expected value. For an example, a company may choose to invest in a project with a 50% chance of success if the expected value is higher than the expected value of a safer project. Simply, this means these are the individuals or organizations who make decisions solely based on expected value. They do not consider about the risk of the project. They only consider about the expected value even though the project is high risk. Risk seeking, risk taking, or risk loving. These are the individuals or organizations actively seek out risks and are willing to accept a higher level of risk in exchange for potentially higher rewards. For an example, a startup may choose to invest in an innovative but unproven technology because they believe in the potential rewards outweigh the risks. Simply, this means these are the individuals or organizations who are happy to take risks. This is the exact opposite for risk averse individuals or organizations. Now let's discuss about how to make decisions under uncertainty. As now you know, there are three risk attitudes: risk neutral, risk seeking, and risk averse. Under each risk attitude, we are going to discuss about what are the decision making criteria. Expected value method can be used when the decision maker is risk neutral. We discussed about expected values method in greater detail. As now you know, in order to calculate the expected values, we need probabilities, which means expected value method comes under risk. And we can use the maximax criteria when the decision maker is risk seeking. And there are two methods when the decision maker is risk averse, which are Maximin criteria and Minimax regret criteria. For these three methods, we are not going to assign probabilities, which means these three methods come under uncertainty. We cannot assign probabilities for these methods. Now let's discuss about these methods one by one. Risk neutral. When the decision maker is risk neutral, decisions are made based on the expected values method. Decision makers are indifferent to risk and make decisions based solely on expected value. Simply, this means they ignore attitudes to risk. They solely make their decisions based on the expected value. If the expected values are in the form of revenue, income, profit, or cash inflow, select the highest expected value option. If the expected values are in the form of expenses, costs, losses, or cash outflow, select the lowest expected value option. Simply, this is the summary of expected value method. When the expected values are in terms of cash inflow, we select the highest expected value option. When the expected values are in the form of costs, we select the lowest expected value option. Now let's do this example. Expected values of profits for each option are given here. There are 5 options. If the decision maker is risk neutral, which option would be selected? So they have calculated the expected values for each option. So simply what we have to do is we have to select the option that a risk neutral decision maker would select. As now you know, if the expected values are in the form of profits, we select the highest option. So what is the highest option? Which is this. So we select the option 3. Is it? No, it is not. This is a negative value. Simply this means this is a loss. 3600. So when it comes to select the highest value, do not make your decision based on the numerical figure itself. So the highest value of these options is option 4, which is 1500. This is the option that a risk neutral decision maker would select. This is a loss of 3600. This is a profit of 1500. Now let's do this example. Expected values of cash outflows for each option are given below. If the decision maker is risk neutral, which option would be selected? So they have given us the expected values for each option and these values are in terms of cash outflows. So we select the lowest expected value option, which is option 5. This is the lowest amount of cash flow among these options. So a risk neutral decision maker would select the option 5 because it has the lowest amount of cash outflow. Now let's discuss about risk seeking, risk taking or risk loving. When the decision maker is risk seeking, risk taking or risk loving, decisions are made based on the maximax criteria. What is maximax criteria? The maximax criteria involves evaluating each alternative's best possible outcome and selecting the one that offers the highest maximum payoff. Simply this means we have to select the maximum value out of the maximum values. This is why this is known as maximax. We have to select the maximum value out of the maximum values. This approach assumes that the decision maker is optimistic and seeks to maximize their gains without considering the associated risks or probabilities. This term is very important. Optimistic. If the decision maker is optimistic, which means the maximax criteria will be used because they want to maximize their payoff. If the payoff table consists of revenue, income, profit or cash inflow, under maximax criteria, the decision maker will select the maximum value out of the maximum values for each alternative. That is why this is known as the maximax criteria. We have to select the maximum value out of the maximum values. If the payoff table consists of expenses, costs, losses or cash outflow, under maximax criteria, the decision maker will select the minimum value out of the minimum values for each alternative. This is known as minimin criteria. This is the exact opposite to maximax criteria. These 2 points are really important. If the payoff table consists of cash inflows, we have to use the maximax criteria, which means the decision maker will select the maximum value out of the maximum values. If the payoff table consists of cash outflows, the decision maker will select the minimum value out of the minimum values. We have to use the mini-min criteria because the decision maker will select the minimum value out of the minimum values. Now let's do an example so you can understand these 2 points. There are three possible alternatives for a farmer to grow in the next crop: wheat, corn and paddy. The table below shows the potential outcomes in terms of profit for each alternative under different scenarios. Which crop an optimistic farmer would select for the next crop? So they have given us the term optimistic, which means we have to use the maximax criteria or minimin criteria. This is because the term optimistic. So what criteria we have to use for this example between these two? They have given us the payoffs in terms of profit, which means we have to use the maximax criteria. We do not have to use the minimum criteria. Let's go back. Here it says if the payoff table consists of profit, we have to use the maximax criteria, which means we have to select the maximum value out of the maximum values. Now let's do this example. These are the alternatives and these are the outcomes. So here what we have to do is we have to select the maximum value for each alternative. So for the alternative 1, which is wheat, we have to select the maximum value, which is 10,000. For the second alternative, we have to also select the maximum value, which is 12,000. 16,000 is not the maximum value. This is a loss. This is a negative value. And for the third alternative, the maximum value is 15,000. So now we have the maximum values. What is maximax criteria? Maximax criteria is the maximum value out of the maximum values. We have selected the maximum values, which are 10,000, 12,000, and 15,000. Now we have to select the maximum value out of these maximum values. So what is the maximum value? The maximum value is 15,000. So we select the alternative 3, which is paddy. So an optimistic farmer would select the alternative 3, which is to grow paddy in the next crop, because paddy has the maximum value out of the maximum values. This is how we can use the maximax criteria. Maximax criteria is very simple. All you have to do is you have to select the highest value. You don't even have to select the highest values for each alternative. You can directly select the value. Look at these values. What is the highest value? The highest value is 15,000. So you can directly select the alternative 3. Now let's do this example. There are 3 possible alternative machines for a farmer to grow paddy in the next crop. The table below shows the potential outcomes in terms of costs for each alternative under different scenarios. Which alternative an optimistic farmer would select for the next crop? So you can see the term optimistic, which means you have to use either maximax or minimin criteria. Since the payoffs are in terms of cost, we have to use the minimin criteria. As you can see, if the payoff values are in terms of costs, we have to use the minimin criteria. This is where we have to select the minimum value out of the minimum values. So these are the alternatives or options and these are the outcomes. So first of all, what we have to do is we have to select the minimum value for each alternative. Since these values are costs, we have to select the lowest value for each alternative. For alternative 1, what is the lowest value? Which is 3000. For alternative 2, what is the lowest value? The lowest value is 5000. For alternative 3, what is the lowest value? Which is 4000. Now we have the minimum values. So minimin means we have to select the minimum value out of the minimum values. So what is the minimum value? The minimum value is 3000. So we select the alternative one, which is machine A. So, an optimistic farmer would select the alternative one because it has the minimum value out of the minimum values. Min criteria is also simple. If the payoffs are given in terms of costs, all you have to do is you have to select the minimum value. You don't even have to select the minimum values for each alternative. You can directly select the minimum value. So the minimum value of these payoff values is 3000. So we can select the alternative one. Now let's discuss about the third risk attitude, which is risk averse or risk avoiding. When the decision maker is risk averse or risk avoiding, decisions are made based on the two criteria. We can use either maximin criteria or minimax regret criteria. A risk-averse decision maker prioritizes minimizing potential losses and considering the associated risks and uncertainties. Risk-averse decision maker is pessimistic and always expect the worst thing to happen. This term is important. When you see the term pessimistic, which means the decision maker is risk averse or risk avoiding, and they always expect the worst thing to happen. So they have to minimize their losses considering the associated risks and uncertainties. So their goal is to minimize the losses because they expect the worst thing to happen. Let's discuss about the Maximin criteria first. The Maximin criteria focuses on minimizing the maximum possible loss or downside. It involves identifying the minimum payoff for each alternative and selecting the one with the highest minimum payoff. Simply, this means we have to select the maximum value out of the minimum values. This approach is suitable when you are more concerned about the worst case scenario and want to protect against potential losses. If the payoff table consists of revenue, income, profit or cash inflow, use the maximin criteria, which means you have to select the maximum value out of the minimum values. Maximin, the maximum value out of the minimum values. If the payoff table consists of expenses, costs, losses, or cash outflow, use the minimax criteria. This is where we have to select the minimum value out of the maximum values. Minimax, the minimum value out of the maximum values. Now let's do this example. There are three possible alternatives for a farmer to grow in the next crop: wheat, corn, and paddy. The table below shows the potential outcomes in terms of profit for each alternative under different scenarios. Which alternative a pessimistic farmer would select for the next crop? Now you see the term pessimistic, which means now we have to use the maximin or the minimax criteria. Since the values are in terms of profit, we have to use the maximin criteria. This is where we have to select the minimum values for each alternative and select the maximum value out of those minimum values. So there are three alternatives and these are outcomes. So now select the minimum values for each alternative. For alternative 1, what is the minimum value? The minimum value for alternative 1 is 2000. For alternative 2, what is the minimum value? The minimum value is 16,000 because this is a loss. What is the minimum value for alternative 3? It is 6,000. Now that we have the minimum values for each alternative, we have to select the maximum value among these values because maximin means the maximum value out of the minimum values. Now we have the minimum values. Let's select the maximum value. The maximum value is 6,000. So a pessimistic farmer will select alternative 3, which is to grow paddy. This is how we can use the maximin criteria. First, we have to select the minimum values for each alternative and then we have to select the maximum value out of these minimum values. Now let's do this example. There are three possible alternative machines for a farmer to grow paddy in the next crop. The table below shows the potential outcomes in terms of costs for each alternative under different scenarios. Which alternative a pessimistic farmer would select for the next crop? Now you know when you see the term pessimistic, we have to use either maximin criteria or minimax criteria. The values are in terms of costs, so we have to use the minimax criteria, which means we have to select the minimum value out of the maximum values. So these are the three alternatives. These are the three outcomes. So let's select the maximum values for each alternative. For alternative 1, what is the maximum value? It is 18,000. For alternative 2, what is the maximum value? It is 16,000. For alternative 3, what is the maximum value? It is 12,000. So under minimax criteria, we are going to select the minimum value out of the maximum values. We have the maximum values selected. So let's find out the minimum value. So the minimum value is 12,000. So we select the machine C, which is the alternative 3. This is how we can use the minimax criteria. Now let's discuss about the minimax regret table. The minimax regret table is a decision making approach that focuses on minimizing the maximum regret associated with a decision. Simply this means we have to select the minimum value out of the maximum regret values. Regret is the difference between the payoff of a chosen alternative and the payoff of the best alternative for each possible outcome. Regret also means the opportunity lost. If the payoff table consists of revenue, income, profit, or cash inflow, the best outcome is the highest value. If the payoff table consists of expenses, costs, losses, or cash outflow, the best outcome is the lowest value. The minimax regret table is bit complicated than the methods we have discussed earlier. So pay close attention. These are the steps to follow under minimax regret criteria. The first step, select the best outcome value for each outcome. If the values are cash inflows, select the highest value. If the values are cash outflows, select the lowest value. The second step is to make the values selected by the above step as the base values for each outcome by assigning 0. Calculate the regret for each outcome value. Regret is also known as the opportunity cost or opportunity loss. If the values are cash inflows, regret is equal to the best outcome value minus other value under the same outcome. If the values are cash outflows, regret is equal to other value under the same outcome minus the best outcome value. So finally, we can apply the minimax regret criteria alternative wise and find the final answer. This is really important. For both cash inflows and cash outflows, the minimax regret criteria is the same, which means do not change it to maximin regret criteria. Let's understand what this point means. If you can remember, when the decision maker is risk seeking for revenue, income, profit, and cash inflow, we use the maximax criteria. And when the values are expenses, costs, losses, or cash outflows, we change the criteria to minimin criteria. Likewise, we change the maximin criteria into minimax criteria. But we do not change the minimax regret criteria into maximin regret criteria. So it will be the same for both revenue and costs. This is really important. Now let's do this example. There are three possible alternatives for a farmer to grow in the next crop: wheat, corn, and paddy. The table below shows the potential outcomes in terms of profit for each alternative under different scenarios. Which alternative will be selected under minimax regret criteria? So let's go back and see the first step. The first step is to select the best outcome value for each outcome. If the values are cash inflows, select the highest value. If the values are cash outflows, select the lowest value. So these are the alternatives or options. And these are the outcomes. So what we have to do is we have to select the best value for each outcome, not for the alternative, for each outcome. Since these values are profit figures, we have to select the highest outcome value for each outcome. So for the outcome of good weather, select the highest value. The highest value is 12,000. For the next outcome, what is the highest value? The highest value is 10,000. For the third outcome, what is the highest value? The highest value is 15,000. 16,000 is not the highest value. This is a loss because this is a negative value. So we are done with the first step. We just selected the highest outcome value for each outcome. Let's go back. The second step, make the values selected by the above step as the base values for each outcome by assigning 0. What this means is we are going to make these values as the base values for each outcome, which means we are going to assign value 0, which comes here. And for the second outcome, it is also 0. For the third outcome, this is 0. This is how we make the outcome values as the base values. So now we are done with the second step. Let's go back. The third step, calculate the regret for each outcome value. If the values are cash inflows, regret is equal to the best outcome value minus other outcome value under the same outcome. Now we have to calculate the regret for each outcome value. For the first outcome, how we can calculate the regret? Regret is equal to the best outcome. The best outcome is 12,000. That is why we selected this value. This is the best value minus the other value under the same outcome, which is 10,000, which is this value is equal to 2,000. This is the regret value 2000. So what will happen to this outcome value? So the best outcome value is 12,000. So the other outcome value is 12,000. This is equal to 0. This is why we assign 0 for the best outcome value. 12,000 minus 6,000 is equal to 6,000. This is the regret value. Likewise, we have to calculate the regret values for other outcomes as well. For the best outcome value is 10,000 minus 8,000, which is equal to 2,000. The best outcome is 10,000. The other outcome value is also 10,000, so it is 0. The best outcome is 10,000 minus 9,000 is equal to 1,000. For the third outcome, the best outcome is 15,000 minus 2,000, which is equal to 13,000. The best outcome is 15,000 minus 16,000. This is a negative value. This 16,000 is a negative value. So there will be two negative values here. So this is equal to 15,000 plus 16,000, which is equal to 31,000. Be careful when there are negative values because two negative values will be a positive value. So finally, the best value is 15,000 minus also 15,000 is equal to 0. So now we are done with the third step. Let's go back. So finally, we can apply the minimax regret criteria alternative wise and find the final answer. Now we are done with the outcome wise calculations. So these are the outcomes, these are the alternatives. we are going to apply the minimax regret criteria alternative wise. So minimax regret. This means we have to select the minimum value out of the maximum regret values. So what are the maximum regret values for each alternative? For alternative 1, there is 2000, 2000 and 13,000. So 13,000 is the maximum regret for alternative 1. For alternative 2, there is 0, 0 and 31,000. So 31,000 is the maximum regret for alternative 2. For alternative 3, 6,000, 0. So 6,000 is the maximum value or the maximum regret. Now we have the maximum regret values. We have to select the minimum value out of these maximum regret values. So what is the minimum value? Minimum value is 6,000. So we select the paddy, which is the alternative 3. So under minimax regret criteria, the farmer will select the alternative 3, which is to grow paddy. As I said earlier, this is bit complicated than the methods we have discussed earlier. So you have to do more example questions in order to understand this method properly. Now let's do this example. There are three possible alternative machines for a farmer to grow paddy in the next crop. The table below shows the potential outcomes in terms of costs for each alternative under different scenarios. Which alternative will be selected under minimax regret criteria? So now you know we do not change the minimax regret criteria into maximin regret criteria. This is the point. Do not change the minimax regret criteria into maximin regret criteria, even though the values are revenue or expenses. For both types, we use the same criteria. So these are the alternatives and these are the outcomes. So the first step is to select the best outcome value for each outcome. So these are the outcomes. We have to select the best outcome for each outcome. Since these values are costs, we have to select the lowest value for each outcome as the best outcome. So 3000 is the lowest for the first outcome. So this is the best outcome. So we assign 0 for this outcome. For the second outcome, what is the lowest value? It is 5000. So we assign 0 to this outcome value. For the outcome 3, what is the minimum value? Which is this. So we assign 0 to this outcome value. We are done with the first and second steps. Now we have to calculate the regret values for each outcome value. Now there is a little difference. Let's go back. As you can see, the calculation of regret when the values are cash outflows is different from the cash flows are cash inflows. We have to calculate the regret by using this formula. Other value under the same outcome minus the best outcome value. This is the opposite of this equation. We are deducting the best outcome value from the other outcome values. Here we deducted the other outcome values from the best outcome value. Remember this point as well. So the other outcome value for this is 3000. The best value is also 3000. So this is 0. The other outcome value is 6000. The best outcome value is 3000. This is 3000. The other outcome value is 12,000. The best outcome value is 3,000, which is equal to 9,000. For outcome 2, the other outcome value is 6,000. The best outcome value is 5,000. This is 1,000. The other outcome value is 5,000. The best outcome value is 5,000. This is equal to 0. The other outcome value is 9,000. The best outcome value is 5,000. This is equal to 4,000. For outcome 3, the other outcome value is 18,000. The best outcome value is 4,000. This is equal to 14,000. The other outcome value is 16,000. The best outcome value is 4,000. This is equal to 12,000. The other outcome value is 4,000. The best outcome value is also 4,000. This is equal to 0. The third step is also done. So now what we have to do is we have to consider the alternative wise. So what is the criteria? The criteria is minimax regret criteria, which means we have to select the minimum value out of the maximum regret values. So let's select the maximum regret values for each alternative. For the first alternative, what is the maximum regret value? It is 14,000. For alternative 2, what is the maximum regret value? It is 12,000. For the alternative 3, what is the maximum regret value? It is equal to 9,000. So these are the maximum regret values for each alternative. Mini max regret criteria. So the minimum value out of the maximum regret values. So let's find out what is the minimum value out of these maximum regret values. So it is 9,000. So the farmer will select the alternative 3, which is machine C. So this is how we can use the minimax regret criteria when the values are in terms of costs. Thank you for watching. See you in the next video.